Hello, my name is Nilesh Ranjan and this is my digital assignment one for machine learning. My topic is K nearest neighbors. So what is K nearest neighbors? K nearest neighbors is an algorithm for classification of data used in machine learning. An example that I presented over here is that we may have three categories of body types, which is underweight, fit, or overweight. So, using these categories, if we put up an unknown category of body type, we can predict which category that unknown type falls in. What is the steps to implement KNN? Step 1 is to start with a data set with known categories. In this case, we have a different body types underweight, fit and overweight. So we'll cluster the data using PCA and we'll plot a scatter plot which will contain all the body types. Now, we'll add a new body type with an unknown category to our plot. After that, we'll classify the new body type by looking at the nearest annotated body type. We'll give a k value and predict what value the unknown category falls in using the k value. How to pick the value of k? There is no best way to pick the value of k. You need to try a few values before choosing one. It starts with a little bit of trial and error. Low values of k, like 1 or 2, can be noisy and subject to effects of outliers. Large values of k smooth over things, but we don't want k to be so large that a category with only few samples in it will always be outvoted by other categories. Now, I'll be demonstrating KNN using a code and explaining what happens when we are implementing KNN.
Now I'll be demonstrating KNN using scikit-learn. I'll be using the dataset iris dataset, which consists of four attributes, which are sepal width, sepal length, petal width, and petal length. This dataset will be containing 150 values, and the associated task with it is classification. It has no missing values. So first, what we'll do is we'll import all the libraries, which are mainly NumPy, Matplotlib, Pandas, and many libraries from the sklearn. The first thing that we need to do is import the dataset. So as you can see here, we have imported the dataset, and then we have assigned the column names to the dataset. Using this, we create a data frame from Pandas, and then we show the first five values of our dataset. Now we'll be proceeding to the next step, which is pre-processing the data. The first thing that we do is split our dataset into attributes and labels. To do so, we do the following: x equal to dataset.iloc minus 1.values and y is equal to dataset.iloc 4.values. This separates our dataset according to our need, which is a dataset which contains the class and one which contains the sepal width, sepal length, petal width, petal length. Then we proceed towards splitting the dataset. We'll be using sklearn train test split function to separate the dataset into a train and test size, which with test size is equal to 0.20, which means our training data will be 80% of the total data and test data will be 20% of the total data. Therefore, uh, out of 150 records, the training set will contain 120 and the test would contain 30. After performing prediction, we can see that we got the results for the 30 test values, which are the different classifications based upon the features. Then we print the confusion matrix and the classification report. The confusion matrix gives us the end error result. We can get an information about the error. We can see that the values are 0, 0, 0 in the upper triangular and the lower triangular matrix, which concludes that we have a precision of 100%. We can also see this using our classification report, which gives us a precision of 1, which is 100% and which is excellent. Therefore, our model performs really, really well. Now I'm calculating the error. of values of k between 1 and 40. After plotting the graph and using the k-neighbors classifier function by sklearn for k equals to 1, and then proceeding towards k is equal to 2, 3, 4 up to 40, I can conclude that my values of k give zero error between 5 to approximately 27 to 28, and they give the most error at around 40. This concludes this video for KNN algorithm. Thank you. I'll be providing the dataset link in the description.